Everyone, welcome to this video series on database management system. So in this video I am going to explain you one of the most important topics in this module, which is normal forms. Okay, I already explained in the intro video that normal forms are very important for different purposes. So let's see. Okay, so as I told you in the previous video, normalization or schema refinement means you take a large table and you decompose it into smaller tables, right? That is normalization. And what is the process involved in normalization, or what we are trying to achieve is normalization actually contains bringing a particular table or relation into a particular normal form. Okay, so in normalization we take the table or relation and bring it into a particular normal form, or check whether it is in a particular normal form or not. If it is not in a particular normal form, we can make it satisfy a particular normal form. Okay, so what are the different normal forms that are there? We have first normal form, second normal form, third normal form, and BCNF, which means boys code normal form. And of course we have other normal forms also, like fourth normal form, fifth normal form, etc. But if your relation table is in BCNF, that is more than enough. Okay, so if your table or relation is in BCNF, that means there is no redundancy. Okay, right. So I hope you understood what are different normal forms and what is the purpose of normal forms. Right. Now I would like to share some important points. So if you take restrictiveness as a factor, if you see here, the most restrictive normal form is BCNF and the least restrictive normal form is 1NF, first normal form. Okay, by restrictiveness I mean more and more rules must be satisfied. Okay, so if you take BCNF, that table or relation follows or satisfies more number of rules when compared to first normal form or any other normal form. Okay, now if you take subset relationship, or you can say inclusion relationship, you can say BCNF is a subset of 3NF, 3NF is a subset of 2NF, and 2NF is a subset of first normal form. Okay, so if you take these two, what can I say from this is every BCNF relation is already in third normal form. Okay, similarly if I take third normal form and first normal form, I can say that every third normal form relation or table is already satisfying first normal form. Okay, right. And the last one is with respect to redundancy or duplication, duplicate data. So the normal form which is having least amount of redundancy or even no redundancy is BCNF. Okay, in the remaining things, third NF to second NF and first NF, there is still some redundancy. Okay, that's why previously I said that if you bring your table relation to BCNF, that's enough. You can stop there. Okay, right. So let's talk about first normal form. So we will start with first normal form, then move on to second, third, and BCNF. Okay, so when can we say that a particular table or relation is in first normal form? So you can see here, if all columns in the table contains only atomic values, then we can say the table is already in first normal form. Okay, so what do we mean by only atomic values? So for that purpose I have given an example here. So if you take an employees table and you consider the mobile column, if the table allows to store 2 or more mobile numbers in the same column, then we can say that employees table is not in 1NF. Okay, I am repeating again. If the mobile column in an employees table allows you to store more than 2 mobile numbers, then we can say that the table is not in 1NF. So if you are able to store two values or more values in a column, then this condition is satisfied. So sorry, not satisfied, right? This condition is violated. Okay. If you want another example, if you take the address, sometimes you will see that while registering in some website, they will ask you address 1 and address 2, or permanent address and current address. For example, in the database table, if you are storing both addresses in the same column, then you can say that the table is not in 1NF. Okay, right. This is very simple. By default, every table in any dbms is already in first normal form, so you don't need to bother about it. Okay, so by default they won't allow you to store multiple values, right? Okay, now second normal form. So if you see here, if there are no partial dependencies in a table, then you can say that your tabular relation is in second normal form. That means counter is, if there are partial dependencies, you can say that the table is not in second normal form. So what is a partial dependency and all these things means, I have to explain you one more thing before that. Okay, so here we will come to the partial dependency later, but first of all, let's see this. Okay, so a relation R which is having three attributes A, B and C is given to you, and they are also giving you two functional dependencies that are there. Okay, so this data is given to you. Now they are asking you to find keys, candidate keys. The question is, what are the keys? Key or more number of keys? If there is only one, you will find that. If there is more than one, you have to find that also. Okay, what are the candidate keys? Right. Now how will you do this? So we will start with single attribute. Let's take A, and you will try to find a closure. So I already explained in the last video how to find attribute closure. If you didn't watch, please go to the previous video and watch how do you find attribute closure. So I will show you here how to do it. So when you are trying to find the closure of a particular attribute, you have to include that attribute in the closure like this. Okay, now you have to check whether in the FDs on the left hand side there is this attribute or not, only that attribute or not. So if you see this functional dependency along with A, there is also B, so we should not consider this. If you see this, it is not starting with A at all, so the closure of A plus is A itself only. Similarly, if you take closure of B, okay, first include that B and check whether any functional dependency is there which is having left hand side that attribute. So here it is. So include the RHS in the closure. So include C here. Now check if there is any functional dependency with C. No, there is nothing. So this is the closure of B. And now take C. Okay, so include C here and check whether any functional dependency is there with C. There is none, so close it. Okay, now how to decide whether A, B, C are keys? So how do you decide is, if the closure includes all three attributes A, B and C, then that can be called as a candidate key. Okay, but if you see here, all these three closures does not have all the three attributes. Okay, so A is not a key, B is not a key and C is not a key, right? Then what you have to do is, you have to take two attributes combination, AB. Okay, AB plus closure of AB. Now as I already told you, since you are finding closure of AB, include AB here. Then you check FDs which are starting with A or B. Okay, so you have AB, so here is the functional dependency with both A and B, so include the right hand side which is C. So all three attributes are covered. So your AB is a key for the given relation, so it's a composite key because it is having two attributes, right? Similarly, You should not stop the process here because you found AB is a candidate key. Similarly, you have to find whether BC is also a candidate key or not. So BC closure. So tell me what will come here. Yes, you have to include BC. Now check whether there is any FD with only B and C here or both B and C. Okay. So with B you have this. So C is already included. No need to include it again. So that's all. There is nothing else. So BC closure is BC itself. So BC does not cover A. Okay. So BC is not a candidate key. Similarly, you can take AC also. So by now I think you know the closure of AC. So include A, include C. Now with C there is no functional dependency. With A there is no functional dependency because there is B here. So we should not consider that. Even if you consider that, C is already here. So this closure is also not covering all three attributes. B is not there. So this is also not a candidate key. Okay, so for this given relation and the given set of FDs, there is only one candidate key, okay, which is AB. So this is the candidate key for this given relation. Okay, now why I told you this process is finding candidate key and all these things. Now since the candidate key is AB, what are the prime attributes? Prime attributes, or you can also say key attributes. Okay, prime attributes or key attributes. So what are the attributes which belong to the candidate key? Those things are called as prime attributes or key attributes. So prime attributes contains A comma B. Okay, what are non-prime attributes or non-key attributes? So attributes which are not part of the candidate key, those are non-prime attributes. So which is C, right? So I hope you understood why I told you this process of finding candidate keys. It is because we need to know what are prime attributes and what are non-prime attributes. If you didn't understand or if you have any doubt, you can comment below the video. I will respond. Okay. So let's go back to the presentation. Right. Now let's discuss about partial dependencies. So what is a partial dependency? So the example I told you is this one only. So the given FDs are this: AB derives C and B derives C. So we found out that prime attributes are AB, right? Prime attributes are AB. So PA prime attributes. And non-prime attributes are only one, which is C. Okay, now what is a partial dependency? Partial dependency means if the right hand side is dependent on only subset of these prime attributes, then you can say the dependency is a partial dependency, right? Understood? Okay, so let me tell you with an example. So if you take this functional dependency AB to C, this right hand side C is dependent on both A and B, that is the full key or all the prime attributes. But if you see this second one, C is dependent on only B, it is not dependent on A, which is also a prime attribute. So this thing is PD, partial dependency. Okay, I hope you understood what is a partial dependency. Partial dependency is a dependency in which the right hand side is dependent on only on a subset of prime attributes. That's all, very simple. Okay, so if such FDs are there, then you can say your table is not satisfying second normal form. Okay, right. So the explanation you can see here, the key is candidate key is AB, so the prime attributes are A and B, like I told you. So if you consider this second FD B to C, you can see that C depends only on part of the key, not all the attributes in the key. Okay, so the table is not in second normal form, right? So if the table is not in second normal form, what will you do? You will decompose the table. Okay, you will divide the table into 2 or 3 tables as you wish. So how to divide the table we will see in the later videos. Okay, but for now I am explaining only what is the normal form, how to say whether the particular table is in a particular normal form or not, right? Okay, now let's consider third normal form. Okay, all right, so let's see what is 3NF. So let me explain you this definition, textbook definition here, and later show you an example. So if you consider a relation R and X is a subset of attributes in R and A is one attribute in the R, so here X is a subset and A is one attribute, then you can say the relation is in 3NF when every FD which is of the form X tends to or X derives A. Okay, for every FD, one of these 3 things should be true. Okay, for every FD of this form, one of these 3 things should be true. So first thing is A belongs to X. That means this FD is a trivial FD. So I already explained what is a trivial FD. So that means A is a subset of X. That means right hand side is a subset of left hand side. Then such FD is a trivial FD. Either this or second one is this left hand side should be a super key. Okay, I already told you how to find the candidate key. So if this left hand side is a candidate key or a superset of that candidate key, that thing is called as a super key. Okay, or there is one more rule. If A, that is this right hand side, is one of the attributes in the candidate key, or you can say one of the attributes in prime attribute set, then you can say that this FD follows third normal form. If all such FDs follows this, I mean satisfies this one of these 3 rules, then you can say that the table is in third normal form. Okay, right? It's simple. If you take any FD of this form and all those FDs satisfy any one of these 3 rules, I am saying it again, not all 3 rules, any one of these 3 rules, then you can say the table is in third normal form. And I would like to mention one point here. Finding whether a particular schema is in 3NF or not, it is a NP complete problem. Okay, it's a hard problem, right? It's very difficult. Why it is difficult means because finding all the keys, I mean candidate keys in a relation schema, given relation schema, is a NP complete problem. That's why finding whether a schema is in 3NF is also a NP complete problem, right? So you can say that a particular table is not in 3NF in 2 cases. So the left hand side X is a proper subset of the candidate key K, or X is not a proper subset of any key. Okay, so we are talking about the left hand side in both of these things, right? Either the left hand side X is a subset, proper subset of the key, that is you have only some attributes from the prime attribute set, or X is not at all a key, not at all an attribute from the prime attribute key set. Then you can say such FD is a transitive dependency. Okay, right. Now let's consider this example. Now consider a table which is having these 2 FDs. Okay, so if you calculate, I mean if you come up with a candidate key, AB will be the candidate key. So you follow the process which I have shown you earlier. So if this is the candidate key, the prime attributes are A and B. Okay, now you take this first FD and you can see that the left hand side is a super key, right? It is a super key, so it is satisfying 3NF. Now you take the second, the right hand side, not right hand side, that is the second FD, C2DE. Now if you see this, the LHS C, it is not part of prime attributes. It is a non-prime attribute, right? So this is not satisfying 3NF condition. Okay. So since this FD is not satisfying the 3NF condition, you can say that the entire table is not in 3NF. It's very simple. Okay. So for saying whether a particular table is in 3NF or not, every FD must satisfy either one of these three rules, right? Okay. So if you didn't understand, please go back and listen to this once again, listen to the explanation once again. You will understand it, right? Now the last one is BCNF. So you can say BCNF is a small modification to third normal form. So what is the modification is, in BCNF they are taking out this third rule. Okay, they have taken out this third rule, right? So every functional dependency should either satisfy this one or this one. Okay, right? Fine. So one point here, BCNF is the most desirable form of normal form. Why? Because there is no redundancy in a table which is in BCNF. Okay, that's why I'm saying BCNF is the most desirable normal form. So it is enough if you bring your table to BCNF, right? Okay. Now let's see this example. So these are the FDs that are given. AB2 derives C and C derives B. Now again the key is AB. Now see here, if you take this first one, so prime attributes are A and B, right? Non-prime attributes is C. So if you take AB to C, AB is a super key, so this satisfies BCNF. Now if you see the second one, okay, if you take LHS, C is not a super key, so this is not satisfying BCNF. So since this is not satisfying BCNF, you can say the entire table or relation does not satisfy BCNF. Okay, but if you take 3NF, this satisfies 3NF, and if you see this one, C is not a prime attribute, but if you see the right hand side is a prime attribute, right? So even if left hand side is not a prime attribute and right hand side is still a prime attribute, you can say that this satisfies 3NF. So if they are giving you this set of FDs and asking you whether this is in 3NF, the answer is yes. But again, if you are given this FDs and they are asking whether it is in BCNF or not, the answer is no. Okay. So you can see here the second FD fails BCNF condition because C is not a super key. But whereas both FD satisfy 3NF condition, so the table is in 3NF but not in BCNF. Okay. So that's it about normal forms. So we have discussed 4 normal forms: first normal form, second normal form, third normal form, and BCNF. Boy is called normal form. Okay. So once again, I am saying this topic is very important for competitive exams, for your semester exams, and all these things. So please focus on this. And that's all. That's it about for this video. So please like the video and subscribe to my channel. And if you have any doubts, please comment it in the YouTube, below the YouTube video. Thank you.